Okay, good afternoon. So today we're gonna go into our last lab for the semester, which is gonna be lab number 10. And the idea for today's lab is to look at the material handling component in Arena, specifically to the use of transporters. You will see that the module that we're gonna start working with today, it has multiple different type of material handling equipment that can be modeled using Arena. Um, Even though we're going to be focusing on the one associated with transporters, the the module and the blocks that we're going to use today can also be used for another type of material handling equipment, such as conveyors and so on. So that term again is on material handling. Um, so as always, I go through some of the slides from previous presentations just to remind you about some important things, like to save your work in your computer. So far, I don't think that we have had any problems with losing information during this semester, but I don't want that to happen towards the end of the semester and specifically during the exam. So make sure that you always save your work. Um, and let's go straight to the new Arena modules, um, which are called advanced transfer, and these are a separate set of blocks that are again for material handling, and there are three types of entity transfers. They're listed here. The first one is connect, in which there is no delay between moving an entity from one block to the other. This is the one that we've been using for most of the semester. Like if you go from the create block to the assign block, that there's no time in terms of moving that entity from that block to the other one. So that's what we call the connect zero delay. Um, However, in some of the labs exercises that we have worked with this semester, we have been using the delay block to describe some type of time in the system or time in, let's say, shopping inside a store and so on. So that's another way to capture, let's say, this transfer or movement time inside a facility. This one is more specific, like we know there's a transferring operation happening and it's following a specific type, it's using a specific type of equipment. So we can use these modules to represent that in our model. So the second type is called route. And this could be non-zero delay, or it could have a constant delay, or it can also use a probability or an expression, probability distribution or an expression to represent that delay between moving from one point of the system to another point in the system. For route, we can animate, or we can have, there's some blocks that we can use to represent space. These are called stations, which are actually used to say, okay, you're located in this specific corner of the space, or you're located in this area of the space. So we can define different stations, as many stations as you need. And then based on the stations that you have created for to represent your system, you can also define segments between stations that can be connections, and also define how long is it going to take for you to move from one station to the other, and so on. So there are also fixed routes. These are routes that are never changing. So if you have a product that is always following the same sequence, You can establish a fixed route, or you can have entity-dependent sequences that are, let's say you have different product families. You can define the route for each product family, and then based on the entity that you are working with at that point, the sequence will be based, or the stations that you're going to visit will be based on that entity-dependent sequence. So that's the route. And then there's another type, which is the connect and route. Both assume no limit on number in transit at a time, and that entities have their own feet. Basically, that you don't need an equipment to take the entity from one point to the other. So for example, when we define our transporters, you need to find a transporter that is available in order for you to move from one point of the area of the system to another point. If there's no transporter available, that means that you're going to wait until that transporter becomes available. In the same way, if you're transferring entities using a conveyor, you need to make sure that there's enough space for the entity to be allocated into the conveyor so you can move from one point to the other. On those connect and route strategies, you might also define a movement from one point to the other without the need of having a separate resource to take that movement or to be seized to perform that movement from one point to the other of the system. So this will make more sense once we get into the example, but I just wanted to make sure that you look into this. So we have the resource constraint transfers. So as I said, there will be occasions in which you will have to limit the total number of entities in transit at a time. For example, in telecommunications, when you have a limit in terms of the number of packets that you can transfer, or in logistics based on the number of vehicles that you have available. For material handling devices, transporters, conveyors, and so on, they typically place limits on the number and capability of these transporters. And these are like resources, right? Like you had to wait for them to become available in order to use them. For conveyors, you have belt, hook lines, escalators. Typically, you have limits in terms of the space. In this environment, in Arena, we define that in terms of windows. So how many windows you have available. If you have 10 windows and each product has the size of a window, then you can accommodate 10 products in the conveyor. So usually you limit the space on the conveyor, and also you have the speed for your conveyor. And then you have also non-accumulating versus accumulating conveyors. Some additional concepts for transporters. This could be carts, forklifts, trucks, wheelchairs, people. Like you can actually define a person moving entities as a person from one point to the other. Obviously, it will have less capacity, but you can still define it. They use transporters as movable resources, and there's some activities that needs to happen in order for you to perform that movement from one point to the other. Activities involve, first, you need to request the transporter. So let's say you only have 2 forklifts for the entire facility, and you need to move a pallet full of boxes. So now you have to wait until that forklift becomes available. So you put a request. Once it becomes available, you can seize that transporter, find the pallet that you need to move, and then perform the action, which is to transport from that point to the next point in your sequence. And after you have completed this transportation action, you can free the transporter. So there's going to be 3 blocks. Each one of them is going to be representing one of these 3 actions. Again, have a request block, a transport block, and a free block. And you have to specify them in a certain way in order for this to work. Um, so as a transporter selection rule, if it is greater than one, transporter is available when requesting. Um, so when three and this selection rule is greater than one, the entity is waiting. The priorities typically by default is going to move to the unit that is making the request, that is the closest one. We have other rules that I think we're going to discuss in a minute. There's two types of transporters. The free path, which is the one that we are going to discuss today, meaning that you are not forced to follow a specific, let's say, hallway or yes, so you're not forced to follow a specific lane. Those can move freely through the facility. Those are easier to specify, so those are the ones that we're going to discuss today. But you can also specify guided transporters, which are typically the AGVs, and then we have a specific route that you can use to move things around. Think about the difference between a railroad system versus a car, right? So the train will follow specific path versus a car can move freely through obviously the streets, but you can decide where to turn and not. So guided versus free path. In today's lab, we're going to focus on the free path. Okay, so let's look at the blocks. As I mentioned, we have a station block. Those are modules that define a station corresponding to a physical or logical location where the processing occurs. So think about like you're getting to a warehouse and you're parking the truck in a dock, right? So that will be the location in which you are going to start moving things from the dock to inside the facility. So that's where the processing occurs. So once you arrive to the station, then you can perform all the things that you need to perform and then move to the sequence. Then we have the route block, and this is a transfer block, transfers an entity to a specified station or the next station in the station visitation sequence defined for the entity. A delay time to transfer to the next station may be defined. So if you go and double click on this route block, you'll see what's shown here. You have the name of the block, route 2 in this case, and then how long is it going to take for you to perform that action. So if you're going to move this to station 3, let's say there's a distance in between, and you can compute the time it takes. You can assign that time, route time in here, and also the destination type. So if you're moving this to another station, you specify the name of the station, and that will happen once you reach this block. So this is the type of transporter or transportation module that will be basically not using a resource like you're routing. Basically, you're assuming that you're moving part from point A to point B. You're assigning time, but you're not requesting a resource to perform that movement. But if you're going to be using some type of resource or transporter, then we have to rely on a different group of blocks. So here we have the request block, or the request module that assign a transporter unit to an entity and move the unit to the entity's location. So again, here it works more like a sys block in which you are gonna have a queue. Like you can see in this block, there's a queue on top of the block. And once you reach this block, since you might need to wait for the resource or the transporter to become available, you'll be waiting in a queue. So when the entity arrives to the request module, it is allocated transporter when one is available. The entity remains in this request module until the transporter unit has reached the entity's location. The entity then moves out of the request module. If you double click here, you will see the instructions associated with this block. So first, you would have to identify the group of transporters that you're going to be using. So that's the transporter name. So you are going to define a name as you define the resource. So this is transporter 1, 2, 3, and 4. So here's where you're going to define the transporter that you're going to be requesting. The selection rule, which we have looked at before, like when you have to choose between different options, which type of rule you're going to follow, it's cyclical and so on. The priority for that station. So let's say you have multiple request blocks and you want to make sure that one of them has highest priority, you can do that. And then the entity location, and what else? The speed in which this transporter or velocity where transporter is going to move, and so on. So this is a request block. And here are the different selection rules. Cyclical, experiment rule, largest distance to station, prefer order rule, random priority, smallest distance to station, and a user rule, which use the selected transporter index UR, where UR is computed in a user code rule functioning. Okay, so we can also get to that level of detail based on the application that you're looking at. So once you do the request, we move to the transport block. This is what transfers the controlling entity to a destination station. For free path transporters are always moved to the same station destination as the entity, right? So let's say for free path transporter, what this is trying to say is let's say you have 4 stations. 1, 3, 1, 2, 3, and 4. So if you are located here, one, two, three, and 4. So for a free path transporter, if you need to go from 1 to 3, you can go straight from 1 to 3. But let's say you are not within this free path and you have a specific path that you need to follow. Let's say you have a path like this. Now, if you need to move from 1 to 3, you know you have to go through 2 and then to 3, right? So that's what this is trying to say. Free path transporters are always moved to the same station destination as the entity. So you go from 1 to 3 directly. If you have a defined path, then you might need to go from 1 to 2 and then go through 3. So those are the fixed path. The time delay to move the entity and transporter from one station to the next is based on the velocity of the transporter and the distance between the stations, which we're going to define in the distance module. When an entity enters the transport module, its station attribute or entity station, dot station is set to the entity's destination station. The entity is then transported to the destination station. So here's the module, the transport module. Again, you have the name of the block, the transporter name that you're going to be using, the entity destination type. So if you're moving from one station to station 0 to station 1, velocity per minute, and guided transport So if you have a graded transporter type, then the entity destination is gonna be listed here.
So,
Yes.
it would seem that the velocity is attached to the transport process, not to the transporter. Is there a way of attaching the velocity that the transporter is gonna go in to the transporter? Rather than,
So instead of listing the velocity from moving from one station, yes. So I get your question. So whether or not we can specify that speed in the actual transporter versus
because it's an actual.
here, yes. So a good question. So here, I think in Arena we are constrained to define it within this network that we are defining. So moving from one station to the other, how fast are you gonna go in terms of moving those entities? And I think this is for pre-guided or pre-path transporters when we are looking at those that are constrained to specific path, then you can also specify the speed. We'll see that in a minute when we are defining the transporters module. Yeah, so we'll get back to that. And then we have the free module, which releases the entity's most recently allocated transporter unit. So once you have completed that movement, then as you did for the release of the resource, you're doing the free of the transporter. If another entity is waiting in a queue to request or allocate the transporter will be given to that entity. If there are no waiting entities at the time the transporter unit is free, the transporter will wait idle at the free entity station location unless otherwise specified in the transporter module. Then we have the distance module. So as you can see, in order to make this work, we have to define many things. Distance modules defines the distance between two stations in distance set of a free path transporter device, right? So essentially, once you have listed all the stations in your system, you have to come up with all the possible arcs that are associated with your combination of stations. For those arcs in which there's no necessary connection, you can always list them with a distance of 0. Or yes, so basically they are not existing. And then for the rest, like let's say you have a network like this, then you would have 4 arcs that should have some type of distance associated with it. The idea is like you, at the end, you have a possible, for all possible arcs, you have a definition in terms of the connection and the distance between them. So from station 1 to station 2, we have a distance of 50. So we'll name station 1 and station 2 here and here, and then specify that distance as part of this distance matrix. The beginning station and the ending stations and distance are used to create the appropriate distance set, which is used during the simulation run by the transporter moving between the specified stations. Then we have the sequence module. It's used to define a sequence for entity flow through the model. A sequence consists of an order list of stations that the entity will visit. For each station in the visitation sequence, attributes and variables may be assigned values in the sequence module. Right? For example, let's say you have 2 parts. Each one has a different sequence of stations to visit. You go here and you will specify the steps. So in this case, you're moving from C2 to C1 and from C1 to the exit system. If there's an assignment of any type associated with that entity, let's say in station C2, you have to define the processing time. You can do that assignment in here. You can click on that module and define the attribute within that module. That happens, let's say you have different entities that will visit the same stations through the system. And let's say you have different processing times in these different machines for different type of product families. You can update every time you visit station what will be the processing time associated with that entity and that station. So that you have that flexibility. And then we have the transporter module, allows the definition of a free path or guided transporter device for entity movement from one location to the other. So in here, you can specify the name of the transporter, how many of them you have. So in this case, we'll have 4. Whether this is free path or fixed path. The distance set that you just defined, you can specify here. And here goes back to your speed, right? So if there's a, let's say a default speed associated with your transporter, you will define it there. But then within the module, you can also say like, for this segment, the speed could be slower or will be different. Then you can specify that within the model itself per minute. And then you can also specify the initial position for your transporters. And I believe those are all the modules. So it took us 30 minutes to go over all of them. So we now want to spend the rest of the time looking at building a model. So I'm going to go straight to one more thing, and then I'm going to show the example. So yes, here. So one thing that I wanted to mention today for this lab is how can we use this information in our output report to make decisions. Let's say you're comparing two different type of layouts for your facility, and you want to say, or you want to decide which one is the best. We can look at some of the performance measures that we are collecting from our report. And specifically for the output report, we typically get our average for each performance measure and also the halfway. So how do we use this information to decide whether there's a clear winner in terms of what will be the best design when you're comparing two designs or two different models in this case? So if I'm highlighting here the 62.11 for the cycle time average with a half width of 7.42. So what this means, this half width, if you add that to this average, that is your confidence interval, your upper confidence interval, and you subtract this number, that will be the lower side of your confidence interval, right? So you will get something like what we are showing here. Let's say, trying to remember. So let's say we are here, right? So you have the 62.116. Your confidence interval will look like, once you do the summation and the subtraction of your half weight, you'll get an interval that looks like this in blue. What the confidence interval is trying to represent is, you know that the real population mean, it is somewhere between those bounds. You don't know where it is, But my confidence interval, let's say, I think for Arena, these are 95% confidence intervals. Your 95% confidence interval is saying that your actual mean, the real value of the mean, is within these bounds. Okay. So let's say we have another system that we are evaluating, and then we end up getting a 59.5 mean or average cycle time with these bounds, right? So now we have this one in blue, this one in blue. There are two different systems, and we are trying to make a decision about which one is better than the other. The question for you is, we know this is lower than this, but can we say with certainty that this system with 59.5 is better than this one with 69, 62, 62.11?
It's a percentage of overlap in problems and reports.
Yes. So the answer is no, because of what you just said. There's an overlap between these confidence intervals. And we don't know if your mean, the actual mean of your experiment is here or here. So in the case, even though you have a lower value here for the average, let's say the actual population mean is here and your actual population mean is over here. In reality, this system will be better than this one. So where I'm heading with this information is for us to be 100% sure that one system is better than the other, and you're comparing two systems, you need to make sure that there's no overlapping between the confidence intervals, right? If there's some overlap and you're making, let's say you're making the decision based on this performance measure, there's some overlap, there's no valid statistical information that will assure you that one system is better than the other. What you want to see is what you're observing here at the top, right? So there's multiple things that you can do to reduce the size of that confidence interval. Like for instance, you can run more experiments. If you increase the number of experiments, let's say you go from 10 experiments to 100, since you are making more evaluations of your system or under different parameters, let's say different conditions, as you increase the number of experiments, those confidence intervals are going to decrease in size. You might get to the point in which you can get a good representation with this higher number of experiments, in which you get those intervals to be small enough in which you don't get them to overlap anymore. And you reach to that point of view, or if you get to that point, then now it's clearly based on the information that you have about those confidence intervals, that one system is better than the other. If we are only basing our information on the cycle time. So now you have 59.5, 62.11. Confidence intervals are smaller. There's no overlap. You can say that the system with 59.5 is a better alternative from the cycle time point of view. Why am I saying this? The reason I'm saying this is because in your projects, you're also going to be comparing, let's say you have your benchmark and now you're proposing adding more resources or changing the structure of your sequencing or so on. You are going to establish that you have a better layout or a better system, or you have an improvement for your system. You need to make sure when you're comparing that against the benchmark that you are getting some strong statistical support. And you can do that from looking at the confidence intervals. And I also believe for this lab in particular, you also have to look into the confidence intervals to make a final decision in terms of the assignment. Any questions on that? Good. Okay. So here's the lab for today. well, the system that we want to represent is here. We have two forklifts, four stations, and then there's a distance associated with the location of these stations. So that's our network. And we have a two-part, I think there's only one part in this case. One part that is gonna be getting into the system and is gonna follow the sequence, goes in, go to station one, and then goes out. Okay, even though we are defining other stations in this model, we are just gonna go through in, one, and out. You're gonna be extending this model in your assignment, right? So you need to add a second part, I think, sequence and so on. But for today, we're gonna just look into a single part sequence in station one with a processing time of 5, and then out. We're gonna have two forklifts with a speed of 40 feet a minute, and then the time between part arrivals. I mean, the parts arriving to the in station will be following an exponential with a mean of 1 hour. And what we want to do is to collect the average number of parts, one completed after 10 days, using a warm-up period of 1. Questions?
So we only have
One sequence,
one
yes.
sequence. And
Because this model you're gonna extend this model for your assignment, and you're gonna be adding a second part, yes.
so is station two never being used?
In this particular scenario, no. In your assignment, yes, you'll be using that one. Any other question? Good. So let's open Arena. And I'm gonna start by saving this model. Okay, so first, make sure that you have access to the advanced process. If you don't have access to the advanced process, go to right-click, template panel, attach, and select the advanced transfer .tpo from the system, and then click open. So in advanced transfer, you are gonna have access to all these modules. And I think what I'm going to do is to set up all the blocks in this window, and then we're gonna edit them. It's easier that way instead of going one by one, because we can copy and paste some of these sequences before we start editing them. So let's start with the create block, which is we're going to be creating some entities, and we are going to perform some assignments, I believe. just in case, let's put the assign block here.
Creation like.
We are not editing
Oh,
yet.
you're just setting up.
We're setting out the blocks. Yes. Okay, and from here, we can start by setting up. We can go straight to the in, or we can, let's do it more fancy. Okay, let's do route. Okay, so route, again, this could be, when you double click here, this could be a 0 time movement. So it can be instantaneously moved to the first station. So even though I'm setting up a route here, that doesn't mean that it's going to be a time delay for moving entities from one point to the other. In this case, we want to set up all the entities in the in station. So I'm using a route just for to illustrate how it works, but we can easily set up this station one. Basically, what I'm going to do is say, I want you to route these entities to this station. And from here, I'm going to request a transporter. And then I'm going to transport. So once it's happening here, we're just focusing on moving things, right? So from station one, we are going to be moving things to the next station. That station one is going to be the in station. And then from there, depending on the part sequence, is going to be moved to station one or station two. So station, transport, then we are gonna have another station. Station two. Once the transporter reach this station, we are going to free that transporter. And then there's gonna be some processing. So once you get to that station, there's gonna be some processing. And once you're done with the processing, you go back to requesting a transporter because you're done. And from there, you transport. So we can connect the blocks here. So this will be station one or station. I know it says station two, but this is representing station one. Station two is going to look exactly the same way. We're going to have the same sequence. So we can just copy and paste. It should be station three. It says station three in the ID, but For some reason, it's not updating. We're gonna update this in a minute. So essentially what we have so far with these blocks are the in station, station 1, station 2. So we're missing station out. So for station out, we are going to call another station. Yes, you call it free. And after you free that transporter, we're going to collect some statistics. And then we dispose. Okay, so you see the connections between or before station 2, they don't exist because the transporter will take care of bringing those items to those stations. But after you get to the station, you need to free the transporter, perform the activity that you're going to perform if you're in station 1 or station 2. And then once they're done, you can move them to the next request block to move them to the next station in the sequence. Okay. So we have all this. Let's talk about the setup. Okay. So let's try to edit some of this. So we have a random expo. We're using the default with a mean of 1 per hour. Assign. We need to assign anything.
Probably part 1, part 2, if we have it.
Yes, let's do that. So part type. We can define this as part type 1 because we are going to have only one for now. And then you're going to route this. So before we assign the routing, let's update the name. So I'm going to call this the in station. I wonder if I can use that name here in station.
Is there a problem with having the name and the station name be the same name?
I don't think so. We can keep them the same. We'll see, but I don't think there's a problem with that. Once this is defined, we can come back to the route. And then this is gonna ask about the destination type. You can choose station in because you're gonna go straight to that station. And there's no time associated with, so you're gonna go from route to end. Then I want to update the names here. So let's call this one station 1. Let's just put them together. Station 1. Station 2. And this one will be out. So from here, we can save this. If we go to station data, we have in station, station 1, station 2. This is not, see. So it should be only 4. It's in station 1, station 2, and out. Okay, so that's our station area. Then we can look at sequence. And we can define the sequence for part 1. So this is going to be part 1. I'll use part 1 sequence. And
Go from the E station to C1 ground station.
yes, so you go to station 1 and then out, right? So you're going to send that entity from route to end, and then that's where the request is going to happen. So what this is going to do is, okay, from here, where do I go? So you go to station 1, and then you move to the out. We also have to define an attribute here.
This time is fun.
Yes, so we're going to call this processing time. So again, multiple things happening here. We went from defining the sequence. We established the sequence for part 1. And then we're also adding an attribute for station 1. I'm not sure why is it showing it's processing time 5. This station name is not right. I don't know why that station is showing up. So let me go back here, sequence, station 1 out. Good. Okay, so we also need to define our distance. So how are we going to name this? No, distance matrix. And from here, we need to define all the arcs or the arches. So we have, it's still showing up a station space 1, station space 2. I don't know why. So station 1 to station 2. we have a distance of 15. Right, I'm building this matrix. So I have from station 1 to out. $20. And I have from station 2 to out also 20. Then I have from in to station 1, 0. We have from in to station 2 also 0. And even though there's no arc between in and out, I'm going to put that as 0.
Is that necessary?
I believe so. We can try without it, but you are more secure in terms of missing. I mean, you might get some transfers, inappropriate transfers if you are not defining the entire network. So just for to be 100% sure, you define the arcs. So I think we got all of them. Should have 7 in total. So station 1, station 2, station 1 out, station 1, station 2. What is that? Those are all. We got all. Okay. So we got the distance matrix. What else we're missing? We need to define our transporters. So we're gonna call this forklifts.
Do we need to attach the sequence we defined to part 1? Would we just define the sequence, we didn't make a connection between them?
We define the sequence, right? Part 1 sequence, right? And we have not so we have the assignment. When we get here, transporter. Oh, we get there. We get there. So we get to define the transporters. This is 2. These are free pad. We're gonna use the distance set distance matrix. We're gonna keep the same. No, we're using 40 per minute. Okay, so we have the distance matrix, number of forklifts that we're gonna use. Okay. Good. Okay. And then from here, so we got to define. So we did the request. We have the part type 1, which we need to use to define the sequence. We had the route, so this is automatic. Get in. Okay, so this is the station name. Do the request. We need to choose the transporter, forklift. And yes, so transporter, forklifts, selection rule, cyclical, entity station. We are gonna use the, which we have already defined for the transporters. So we will be using the by default. And then we get to the transport. We define the transport name. We can specify the entity destination by sequence. And yeah. And yeah. So I think we are. Where did the unit number? No, because this is to identify which unit you're gonna call from the group of 2. I think what we are missing is an attribute that we need to define for the part type. And that attribute name is NS, if I remember correctly. And this is actually defined as other. So NS for number and sequence. And that'll be NS1 in our case. Let's see if that works. So when it gets here, it says it's by sequence. And it goes to the entity destination. Okay. Okay. So NS should take care of that sequence assignment. If you have more than one, then you have to define an NS sequence for part type 2. So in that case, you will define NS equal to for your part type 2.
And does that mean that you have another sequence in the sequence tab named like part 2 sequence?
For not for this lab, but for the
Homework.
homework, yes. You will have another sequence, yes. Okay, so where we at? We got to station 1. And then we're gonna free the transporter forklifts. And in process, we're gonna have a sys delay release. I don't know, how do we call this resource? We didn't the same machine one. And the time it takes is gonna be based on expression in minutes. Is it processing time? What was the definition, the name?
Engineering process.
Processing time. Okay. Then you're gonna come here, you're gonna request forklifts, right? So you're gonna be calling the forklifts and then transporter name, forklifts, entity by sequence. Okay. And then station 2. Very good. You are gonna free transporter forklift processing. In this one, we don't have a processing time because it's not being used, but I'm going to define scene 2. And then you will edit this based on the requirements for your assignment. And then here, you also request the forklifts. And then you transport based on sequence, entity destination. And then you get here, out, free, forklifts, and then record. Am I going too fast? Counter name. What are we collecting here? Number of parts completed. So parts completed. Dispose. Okay. So let's see if this works. We can check after saving, check the model. Says no errors. So let's set up the model. We're gonna do 10 replications with a warm-up period of 1 day. And this is gonna be for 10 days. I'm gonna apply this. Let's go. Let me check. Base time minutes are minutes. Thank you. Project parameters, and then the reports. Okay. I know we're missing the output report. We're gonna get that one in a minute. Just want to make sure that this is working. Yeah, so it's working. Yeah, do you have questions? I run this. Yes. Got it? No? Let me set up the output report and then I'll take questions. So statistics. This is output and see what's completed. Okay. Yeah, so that should be the output. 217. I think it matches this number, which is the one that I was looking for. So 217.10. Questions? Were you able to get that number?
Yes.
Good.
I'm having issues with, it's giving me an error for not recognizing the way that I set up on stations. I think that's just because I have a weird naming convention.
Yes, so if you saw when I was working in my model, station one shows up twice, station two. So if you're not choosing the right one, you,
It's telling me that I'm not calling the right station, that I don't have any binary distance, but
okay, I can go check. Let me just stop the video